All right. So today we are talking about Unit 3, Day 2. We either started class by going over the Unit 3, Day 1 homework, or if I'm not there, we will finish class by going over the Unit 3, Day 1 homework. Please make sure that you submit that. We're going to start with the Unit 3, Day 2 warm-up, then the Unit 3, Day 2 notes. Please go ahead and open up ClassKick. We have the Unit 3, Day 2 warm-up. This should be shared with you on ClassKick. If it is not, please send me an email letting me know. Okay. I want you to skip over the first day, which is just vocabulary from before, and I want you to go to the Day 2 warm-up. Please pause this video now and give this a try. Use the notes if you need a refresher. Okay. The first thing that we want to do is we want to name the pair of corresponding angles. Remember, corresponding angles have corresponding position. That's how we determine that they are corresponding. When we have two lines that are cut by a transversal, here's our transversal line, here's our two lines. We have 8 different angles that are created. These 4 right here and those 4 right there. We can label them using their position. Top left, top right, bottom right, and bottom left. You don't always have to do this, but it just might help with corresponding. We can also do the same with the bottom 4. We have the top left, top right, and bottom left. The angles that have corresponding position are our corresponding angles. So we have angle 1 and angle 3, both of the top left angles. Angle 5 and angle 7, both of the top right angles. Angle 2 and angle 4, both bottom left angles. Angle 6 and angle 8, both of the bottom right angles. Those are our pairs of corresponding angles. Corresponding angles have corresponding position. The next type of pairs that we're going to look at are our alternate interior angles. Alternate refers to them being on opposite sides of the transversal line. We already identified the transversal line. We want angles that are on opposite sides of that line. That's what alternate means. Interior refers to these 2 parallel lines. So not only do we want angles that are opposite of this transversal, alternate, we want them to be interior to these 2 parallel lines. So they need to be inside of those 2 lines. Alternate and interior would be angles 2 and 7 and angles 6 and 3. So we have angles 2, 7, and angles 6 and 3. Those are our 2 pairs of alternate interior angles. Now, we run into this a lot. Well, you said alternate and interior. Why couldn't it be angles 2 and 6? Think right now if there's another angle pair name for angles 2 and 6. You may have come up with linear pair. Those 2 angles create a straight line. They're not going to be alternate interior angles. They're going to be a linear pair. So we can't say 2 and 6 and 3 and 7. Name the pairs of consecutive interior angles. Before we do that, I just want to show you the pairs of alternate exterior angles. 1 and 8, 5, and 4. They're on opposite sides of the transversal, and they are outside the 2 parallel lines. That would be alternate exterior. Consecutive interior pairs. Consecutive refers to them being on the same side of the transversal. So on the same side of the transversal, and still, we already defined interior, inside these two parallel lines. I have 2 and 3 and 6 and 7. Those are my two pairs of consecutive interior angles. They're on the same side of the transversal, and they are inside those two lines. Now, what about consecutive exterior angles? Well, we'd have 1 and 4, and we'd have 5 and 8. Those would be on the same side of the transversal and outside of the two lines, outside of those two lines. Now, problem 4 may have been a tricky one. You may have been confused. You didn't know where to go. That's okay. The figure below, or to the right, shows a painting easel. You may not even know what that is. It's a tool used for painting. It's okay if you didn't. Does line AB appear to be parallel, perpendicular, or skew to line CD? Here's line AB, and here's line CD. Now, one thing you can tell me right away, are these lines ever going to intersect? Probably not. So right away we can cross perpendicular off our list. That's the only type of lines out of parallel, perpendicular, and skew that intersect each other. This one's tough to see. But if I have two lines that are on the same plane and they do not intersect, those are my parallel lines. Parallel lines are on the same plane and they don't intersect. But skew lines are on different planes and they don't intersect. So they're on different planes and they don't intersect. That's skew. But the problem with this problem is that you can't really tell if these are on the same plane or not. So we can't really assume that they're not on the same plane. I'm just going to say parallel. I can't tell if they're on different planes. If the problem was more specific and gave this a plane and gave that a plane, then that's different. So if the problem instead looked like this, where they're on maybe different planes or at least slightly different planes, right, then we could say skew. But right now we just don't have enough information to say skew. Okay, what I would like to do now is transition to the notes. So please get your note packet out. Day 2, parallel lines and transversals. What we're going to be able to do is use properties of parallel lines to find angle measures and prove that lines are parallel. Very small proof, right? Kind of prove, right? All we're going to be doing is using our properties to say we are 100% sure that these lines are parallel. But we'll see that later. Just a little bit of review here. Use the diagram of the two parallel lines cut by a transversal. So I have these two lines that are parallel to each other. So maybe they have the same symbol. Let me draw that symbol in. There's our symbol letting us know, hey, these lines are parallel to each other. That little arrow symbol. A and D. A and D, well, they're on the same side of the transversal, but one of them is exterior and one of them's interior, so it's not going to be consecutive interior, consecutive exterior. Those are actually going to be corresponding. This angle right here is in the top left. Angle A is in the top right. Angle B is in the bottom left. And angle C is in the bottom right. And looking at angle D, that's in the top right. So all we kind of do is have to match that. Angle A and angle D are corresponding angles because they have corresponding positions. The next angle pair that I want to look at, angles B and D. There's my transversal line. They're on opposite sides of the transversal. They're inside the two parallel lines. That would make them alternate interior. Those are my two alternate interior angles. And lastly, we have angles C and D, which are on the same side of the transversal and again are both interior. We would say consecutive interior. Consecutive tells us same side. Interior tells us inside those two parallel lines. Parallel in this case, not in any of the cases on our first notes, or didn't need to be at the very least. Okay. We have 1, 2, 3, 4, 5 properties that we're going to take a look at here. 3 are very similar. The other 2 are similar to each other. Corresponding angles. If 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. And this is only true for parallel lines. So if I have a problem like I did over here, right, where these were corresponding angles, these don't necessarily have to be congruent because these lines are not parallel. But looking down here, we have parallel lines cut by a transversal. So any corresponding angle pairs are congruent to each other. So we'd have angle 1 and 5, angles 2 and 6, angles 4 and 8, and angle 3 and 7. Now let's just say that angle 1 measured 110 degrees. We said that that's corresponding to angle 5. What would angle 5 have to be? Well, it also has to be 110 degrees because they're congruent to each other. Alternate interior angles. If 2 parallel lines are cut by a transversal, the pairs of alternate interior angles are congruent. Alternate interior angles are congruent. So I have angles 3 and 6 and angles 4 and 5. So let's just say that angle 3 was 70 degrees. What would angle 6 have to be? Well, it also has to be 70 degrees. Right? They have to be congruent. And it would be the same for 5 and 4. Similarly, alternate exterior angles. If 2 parallel lines, again, still parallel, are cut by a transversal, then the pairs of alternate exterior angles are also congruent. Alternate exterior angles are congruent. So I have angles 1 and 8. Opposite sides of the transversal, and they're outside the parallel lines. 1 and 8, and I also have 2 and 7. If angle 1 was 110 degrees, angle 8 would, well, also have to be 110 degrees. Excuse me. Same with 2 and 7. But one change that we have. Consecutive angles. Anytime we have alternate angles, whether they're interior or exterior, they're always congruent. But anytime we have consecutive angles, it's not going to be congruent. If 2 parallel lines are cut by a transversal, the pairs of consecutive interior angles are supplementary. Supplementary angles add up to, hopefully you said 180. Consecutive interior angles are supplementary. They will add up to 180. In a very similar way, consecutive exterior angles are also supplementary. So they're also going to add up to 180. Remember, consecutive angles are on the same side of the transversal. So angles 4 and 6 would be consecutive interior angles. So if angle 4 was 110 degrees, let's draw that a little better. If angle 4 was 110 degrees, what would angle 6 have to be? I know some of you probably just immediately thought 110, but angles 4 and 6 are supplementary, which means that they add up to 180, which would make angle 6 70 degrees. If angle 1 was 110 degrees. What would angle 7 have to be? I know that they're consecutive because they're on the same side, and they're both outside of those parallel lines. Well, they got to be supplementary. That's consecutive exterior angles, so that would make that 70 degrees. But we're going to see some more examples, right? Especially like this. It's the properties that we got to know. So anytime you're looking at consecutive angles, they're always supplementary. Anytime you're looking at alternate angles, they are congruent. And anytime you're looking at corresponding angles, they are also congruent. Okay. Jumping over to our first example here. Notice that I'm looking at two parallel lines that are being cut by a transversal. For the ease of this problem, I labeled this 120 degree angle as angle 1. I would do the same as well. Name that angle 1. We're going to find the measure of all of these missing angles. There are 7 more in this picture. The first one that I want to look at is angle 2. Is there any relationship that we maybe already knew going into this unit about angle 1 and angle 2? Well, they create a straight line, which we've already seen pairs of angles that create straight lines. Those are called linear pairs. Linear pairs, if you remember, are supplementary. So if angle 1 is 120 and angle 2 is supplementary to that, angle 2 should be equal to, hopefully you said 60. Angle 2 is 60 degrees because it forms a linear pair with angle 1. You don't need to write this every single time, but I would for this first example, just to help you understand where these answers are coming from. Okay, well, how about angle 3? There's 2 ways that we can find angle 3. I now know that this angle 2 is 60 degrees. Well, we have another linear pair here, right? We have angle 1 and angle 3 that create a straight line, just as we found angle 2. But I also have 2 angles that are formed by these intersecting lines. What do we call these angles right here? Angles 2 and 3. We call them vertical angles. Vertical angles are congruent to each other. So if angle 2 is 60, angle 3 has to be 60 as well. Angle 3 is 60 degrees because it is a vertical angle with angle 2. You also could have said linear pair with angle 1. The last one that we have in this picture is angle 4. Many ways to do it. I could see a linear pair here. I could see a linear pair here. And I could see vertical angles right here. I'm going to go the vertical angle route. Angle 4 has to be 120 degrees because it's a vertical angle with angle 1. Right, that first angle that we had, 120 degrees. Okay, now we're going to jump over to this other side. We don't know any of those angles, so we might not just be able to use linear pairs and vertical angles, which is what we kind of already knew going into this unit. Angle 5. Many different ways that I can go about this. One way would be alternate interior angles, consecutive interior angles. But the way that I want to go is I want to go with corresponding angles. I have that this 120 degree angle, angle 1, was in the top left of those 4. Well, angle 5 is also in the top left of those 4. So they are corresponding angles. Meaning, angle 5, well, that's also going to be 120 degrees because it's corresponding with angle 1. Now that I know that this is 120, I actually don't need to do much more to find the rest of them. But I'm going to show you how you can see some different angle pairs involved in this, instead of just linear pairs, vertical angles, and corresponding. Because yes, we could just say 60, 60, 120, 120, and 60, 60 by using our corresponding angles. Excuse me. But instead, we're going to look at some different pairs. I'm looking at angle 6 here. Is there a relationship between angles 1 and 6 out of the 4 angle pairs that we've looked at? Yes, there is. They are consecutive exterior angles. Consecutive because they're on the same side of the transversal, and exterior because they're both on the outside of those parallel lines, 1 and 6. So that means, according to our properties here, consecutive exterior means that they're supplementary, so angle 6 has to be 60 degrees. How about angle 7? Let's see if there's a relationship between angle 1 and angle 7. Opposite sides would tell me alternate, but one of them is exterior and one of them is interior. There's not a direct relationship between angle 1 and angle 7, but that doesn't mean that we can't find its measure. We could use alternate interior angles, angle 2 and angle 7. They're both interior and they're opposite sides of the transversal. Alternate interior, sorry, that was 60. That means that's also going to be 60. We also could have looked at consecutive interior. Angle 4 was 120. Angle 7 is the consecutive interior angle, and they have to be supplementary. The last one that we have is angle 8. Think if there is a relationship between angle 1 and angle 8 based on the ones that we've seen. Yes, there is. Here's my transversal, my 2 parallel lines. They are alternate, opposite sides of the transversal, and exterior, both outside the 2 parallel lines. Which means that they are alternate, and anytime we see alternate, we know that those angles are congruent. This one's 120, that one's also going to be 120. Many different ways that we could have gone about solving for each of those, right? We could have used a very basic linear pair, vertical angle, linear pair, corresponding, and then linear pairs and vertical angles the whole way around. But I wanted to introduce some different angles and some different pairs that we were just introduced to last time. I want you to give this one a try. Pause the video right now while I go grab my water and try this problem out. Okay, so right away, I labeled that angle as angle 3. You got to switch this over to angle 1 because we don't have an angle 3, right? This is our angle 3, so make sure you switch that over. But you didn't really need that to find everything else. Angle 2. Angle 2 is the first one, and I think one of the easier ones to find. Those angles are formed by intersecting lines. That means they're vertical angles, which means that angle 2 is going to be 75 degrees. I'm going to go through these a little quicker. Angle 1. Well, let's look at that relationship between angle 3 and angle 1. That creates a straight line. Straight line tells us linear pair, which means that angle 1 has to be 105 degrees. What's angle 4? Answer in your head. Angle 4's got to be 105 degrees. 2 reasons. Linear pair or vertical angles. 5, 6, 7, and 8. You could use corresponding angles the whole way through. I'm going to throw some different ones at you. Angle 1 is in the top left. Angle 5 is in the top left, which means that angle 5 also has to be 105 degrees. Corresponding position, corresponding angle measure. Angle 3 was 75. Angle 6, well, that's on opposite sides or alternate sides. They're both interior. So that tells me that angle 6 has to be 75 degrees because we have alternate interior angles. I know that angle 7 has to be 75 for a lot of reasons. We have vertical angles, which tells me that's got to be 75. I have a linear pair, which tells me, well, that's got to be 75. I have corresponding angles, both in the bottom left, so I know that they got to be 75. And then we have two last options. Consecutive exterior angles, same side, both on the outside. That tells us that it has to be 75 degrees. They're supplementary. And then the last one that we have, alternate exterior angles, which tells us that has to be 75. So I think I want to say it was 5 different reasons why we could have said that that was 75 degrees. Then the last one that we have, 105 degrees. Pick any reason you like. There's many there. Vertical angles, linear pair, corresponding angles, consecutive exterior angles, alternate exterior angles, bunch of different options. Okay, moving on to some algebra problems that we're going to see. We need to solve for x. I have this angle and that angle. I can try and make a relationship with these two, but there is none. There's no immediate relationship between this angle and this angle. They're on opposite sides of the transversal, but one of them is exterior and one of them is interior. That's no good. There's no relationship between them. But instead, can I find the measure of angle 4? Think about that for a second. Yeah, it's 115 degrees. Because 115 degrees here and a vertical angle there, right, I know that vertical angles are congruent. We had to find that first. Now I have this angle right here is 115 degrees. Let's see if there's a relationship between this angle and this angle. They're on the same side of the transversal. They're both interior, which tells me consecutive interior, which tells me that this angle and that angle are going to be supplementary. I add them together and I set them equal to 180. Combine your like terms. Subtract 120 from both sides, and I get x is equal to 60. Unfortunately, we couldn't solve for it right away. We needed to find another angle first. But once we did, we just used one of our new angle pairs that we learned. Okay. Let's see if there is an immediate relationship between these two angles. There is, but if you didn't see it, it's okay. Maybe try and find angle 1 first. Well, angle 1 and that angle are a linear pair because they form a straight line, meaning that that angle has to be 44 degrees. Now that we know that, we have 2 options for solving for x. Not just one anymore. Let's look at the option where I have this angle, angle 1, and this angle, 7x plus 9. I know that that becomes a 44-degree angle. Well, there's my transversal. Are these two angles on the same side or opposite sides? Are they inside the two parallel lines or outside the two parallel lines? So that would make them alternate exterior angles. And alternate exterior angles are congruent. So I would say 44 is equal to 7x plus 9. That's one way I could go about it. Another way that I could go about this is looking at the direct relationship without having to find angle 1 first. These two angles are on the same side. Are they both inside or outside? They're both outside those two parallel lines, which tells me that they are consecutive exterior angles. And consecutive exterior angles are supplementary. Whoops. Those two angles, when added together, will sum to 180. 136 plus 7x plus 9 is equal to 180. No matter which way you solved, you should have gotten x is equal to 5. But it took a little bit of work to get there. I'm not just giving you a problem like this anymore. You need to look at the figure and identify it and find the angle pairs and find the relationships that we talked about. I'm going to open these two up for you. Pause the video right now and give these a try. With both of these, what I want you to think first, is there a relationship between the two angles that I'm looking for? Or maybe the two angles that I'm given? If not, what can I do to maybe make a relationship between two different angles or one of the different angles? Give those a go. Okay. Hopefully you paused the video, but gave yourself a chance to work on it. If not, pause it now. Well, I know that this angle is going to be 120 because it's a vertical angle. And just a hint, there was no angle relationship between this one and that one. They're on opposite sides. One's interior, one's exterior. No relationship there. So we need to make a relationship happen, maybe with a different angle. I see a vertical angle here. That's 120. 120 and 2x, well, those have a relationship. They're consecutive interior angles. They're on the same side of the transversal, and they are inside my parallel lines. I get x is equal to 30. For the next one, was there an angle relationship? Yes, there is. They're on opposite sides of the transversal, which tells us alternate. They're both outside the parallel lines, which tells us exterior. And I know that alternate exterior angles are congruent. So I go back down and I look. Well, I see 6x minus 3, and that's going to be equal to 129 because they're alternate exterior angles. Don't make algebra mistakes. Add your 3 to the right side. 6x is equal to 132, and I get x is equal to 22. The last thing that we're going to talk about is actually proving that lines are parallel. And that sounds a little worse than it actually is. If two lines, or I guess just proving that lines are parallel, if the angle relationship is there, the ones that we were just looking at, if I'm looking at two lines cut by a transversal, and I don't know if they're parallel or not, but the angle relationship is there, then that means that they are parallel. So for example, If two lines are cut by a transversal, notice these aren't necessarily two parallel lines. We may not be given that. But if two lines are cut by a transversal so that the corresponding angles are congruent, that tells us that the lines are parallel. That tells us that these two lines have to be parallel to each other. If they weren't, then those two angles wouldn't be equal to each other, but they are. If two lines are cut by a transversal so that alternate interior angles are congruent, well, then those lines have to be parallel. Because if these weren't congruent, then those lines could not be parallel. For both of these, we would say line J is parallel to line K. If two lines are cut by a transversal so that their alternate exterior angles are congruent, then those lines have to be parallel. We would say J is parallel to K. If those angles weren't congruent, then those lines would not be parallel. And the last one that we got that goes for interior and exterior. If two lines are cut by a transversal so that the consecutive interior angles are supplementary, notice this is the only one that's not congruent, right? Because we're looking at consecutive angles. Those lines still have to be parallel. If angles 3 and 5 were not supplementary, then these lines could not be parallel. But that's not the case. So J is parallel to K. If the proper angles are congruent or supplementary, then the two lines are parallel. Vice versa. If the lines are parallel, then those angles have to be congruent or supplementary, depending on the pair. All that's going to do is just change some verbiage here. We still solve in a very similar way, but it's just going to change the way that the question is phrased. Find the value of x that makes m parallel to n. That sounds a little complicated, but don't overcomplicate it for yourself. We're still looking at two corresponding angles. I know that corresponding angles are congruent if these lines are parallel. So, if these lines are parallel, then I know that these angles are congruent. So I would say 3x plus 5 is equal to 65. 3x is equal to 60, and I get x is equal to 20. This is the value of x that makes those two lines parallel to each other. It makes them parallel. And all I did was solve it just as I would a problem like this. Now we want to find the value of x that makes line M parallel to line N. Well, I have these two angles, they're on the same side, so they're consecutive, and they're both exterior, so they're consecutive exterior, which means that those angles need to be supplementary. Because they're supplementary, 72 plus 4x plus 5, 4 times x plus 5 is equal to 180. My first step is going to be to distribute. Distribute that 4 to the x and to the 5. Now I combine my like terms, 72 and 20. That gets me 92. Subtract that to the other side. I have 4x is equal to 88, and I get x is equal to 22. So I now have the value of x that's going to make m parallel to n. Okay. From here, I want you to give these a try. Problem 1 is a little easier, find the value of x. Problem 2, you need to explain it a little bit. Go ahead. Okay. Looking for the value of x that makes m parallel to n. Well, if these were parallel, then I know that these corresponding angles would have to be congruent. Corresponding angles have to be congruent. So I solve for x. And I get that x is equal to 72. That's going to make those angles congruent. And the last one that I have, this is a little tougher. I wanted you to explain a little bit. Is there enough information to conclude this? Well, are these actually consecutive, I don't know why I said interior, exterior angles? Are they actually consecutive exterior angles? Well, let's find out. If they were, then they would have to be supplementary. I check if they're supplementary. Yes, they are. So they have to be consecutive exterior angles. Again, using interior because I can't read exterior. So yes, we can confirm, we are 100% sure that line M is parallel to line N because these angles are supplementary. We could do the same thing with our alternate interior angles, with these corresponding angles, so on and so forth. Okay. Hopefully you went through the video, and as you were going, you paused to try these problems yourself. Your homework is Unit 3, Day 2 on on Big Ideas. So go ahead and give that a try. And at this point, hopefully period 3, I should be back, but we'll see just in case I'm not. Go ahead and give that homework a try. You need to show work on problems 4 through 8 and 11 through 15. If you have any questions, please let me know. Please send me an email.